I think we've given enough time for everyone else to log in. Hoping that you've been well since the last time that we typically had sessions. So as far as today's session is concerned, we want to look at learning unit number 3, just expanding on the protocols that we mentioned and discussed in our previous session. I think the main purpose as far as today's particular session is concerned is just looking at comparing different access methods that are out there and understanding exactly what's happening with those distinctive standards that we talked about as far as the IEEE is concerned. So the Institute of Electrical and Electronics Engineers that is supposed to typically look at standardizing certain aspects as far as network communication is concerned. So ultimately, just looking at those standards, comparing each one of them and understanding exactly how they function, and then ultimately also discussing the different types of protocol platforms, and then probably delving into topologies as well, just to understand exactly that structure of the network that we've mentioned before. In essence, looking how you can distinctively lay it out and understand how these particular platforms distinctively function, and probably just looking at comparisons between TCP/IP and to some extent some of the AppleTalk and Linux-based platforms as far as generic connectivity is concerned. Now, remember, before we get into it, let me see if I can just reiterate what we mentioned as far as the actual practical part of your POE there is concerned. Remember, we mentioned that there's a cable that you obviously need to design and come up with, which is your straight through Ethernet cable. I think now that we are in level 2, hopefully that we stay on that path or even go below. We should have our face-to-face session scheduled, and then we'll see how we can pan that one out. So obviously you'll need to typically, I think it's about about 2 meters as a distinctive length that you'll need to work with as far as creation of these network cables is concerned. So obviously I think in our next 2 or 3 sessions, we'll start talking about cabling. And then in those sessions, obviously, we'll just get into the nitty-gritties of what's happening and understanding exactly what's happening with category 5E and 6 cabling, and so that you know exactly what you then obviously need to do as far as making these cables are concerned. I think most of you might have already done this before, so it's just regurgitating. But for those who haven't, still all well and good. We'll give you a heads up in terms of what's happening as far as creation of those cables there is concerned. Now, the other part of the POE, like we've mentioned before, is looking at virtualizing the environment that you are typically supposed to work with. Because if we go back here, let me just see if I can go back. So here, let me just typically say your POE, all right, assessment there. As far as this is concerned, remember you're supposed to create a virtual environment. So like we said before we again get into the order of the day, you are going to set up a client, all right, that is going to be connected to a switch that is going to be connected to your server. So that's the kind of setup that you are going to typically create. So obviously, in a real life setup, you've got these 2 physical machines. One that you will install your client software, which is your Windows 10 Pro. And then you've got your switch, and then one that you will also install server software, which is obviously going to be your Windows server. 2012 R2. All right, so you can either go with data center or standard, whichever one that is applicable there. And then, so you're going to virtualize this environment. So I'm just going to list again what you will need as far as the actual softwares would go, so that you've got that on record at least, and you can probably get that cracking to enable you to get a bit of a head start on that. So this is the environment that you'll need to typically virtualize. All right. So like I was saying, if you actually were looking at it from a physical point of view, you've got two machines that you actually need to have. One of those machines you'll need to have Windows, your Windows 10 installed there. One of the other machines you'll need to install Windows Server on it, and then you'll need a switch, and then obviously you are using your distinctive your Ethernet cable for connectivity. All right, so you've got your Ethernet cable there, and that can be what they call Cat 5e or Cat 6. It all depends. All right. So that's your Ethernet cable there. That's your Ethernet cable as well incorporated there. So you're going to virtualize this typical environment. How are you going to do that? Like we said before, you're going to be working with either VirtualBox or VMware. Like I was saying in our previous session, that preferably the VirtualBox is more user-friendly type of a virtual platform. But ultimately, like I said before, whichever one that you're comfortable with, as long as you can distinctively mimic what you've typically got on screen there. So ultimately, as far as the actual software that will then enable us to create our virtualized environment. So here, let's just mention that the actual requirements that you will need. So both software and hardware related, associated with that particular section. So ultimately, the first thing that you need to obviously take into consideration is a processor that is capable of virtualization. See, what's happening now? We want to erase this. Right, so a processor that is capable of virtualization, right? That's one thing you need to take into consideration. Normally, you'll need to obviously activate this in BIOS first. So you need to typically find or confirm that either the machine that you've got at home, whether it's a desktop or a laptop that you've got for this particular module, does it support a virtualization? All right. Obviously, if it supports virtualization, we're good to go. Remember, we've mentioned this in computer architecture before, that the whole concept of what's happening as far as virtualization is concerned is just the ability to run multiple operating systems concurrently or simultaneously or at the same time. And naturally, you will obviously need a specific processor that provides for that architecture there. All right. And then secondly, you should be sitting with at least 8 gigs of RAM. All right. So that is at your minimum, because what is going to happen as far as this particular subdivision is concerned, just to make sure that we can work appropriately as far as your distinctive virtualized machines there is concerned. What we want to do is make sure that you've got 2 gigs set aside for your client in the virtual environment. You've got another 2 gigs for your server. And then naturally, you've got 4 gigs for the actual host. All right, so you want to avoid a glitchy environment. So, and like I said, that absolute minimum, because remember, when you're looking at it even from a basic perspective, the minimum amount of RAM that is needed for you to run your client, say your Windows 10 on a very basic platform, is 2 gigs minimum. Same difference would apply for your server. And then remember, your host will, the moment you run your machine. So if you're sitting with an 8 gig machine, as an argument, if you've got your client in the virtual environment running, if you've got your server in the virtual environment running, that means that already of the 8 gigs that you've got installed there, 4 has been dedicated to your virtual machine. So which means, or your virtual platform, which then means that you only left with 4 for the actual host itself. So you want to avoid obviously a glitchy environment where if both of both of your machines are running, your system is a bit slow or technically starts to hang dependent. You want to just make sure you avoid that. So on a minimum level, 8 gigs would be typically appropriate. Obviously, as that would mean anything more than that would be applicable, just to avoid, again, like I said a couple of seconds ago, an environment where it becomes a bit difficult for you to run those machines concurrently. Because remember, you need to also then show a link between these two machines. Remember, we said before that as far as your servers are concerned, these particular machines are machines that have been designed, obviously, to provide a distinctive service or a dedicated service within the actual network environment that you've got configured. And what's happening as far as those services would go, like we've mentioned a couple of times now, you've got email, you've got DHCP, you've got file, you've got proxy, you've got web, you've got application. The list will go on and on in terms of what the actual server can provide for. So obviously, when you load your server software, again, like we said before, we'll actually have an actual practical session that will show us exactly how we can go about this. You then need to add what they call roles. So you just install. So when you look at the client, when you install Windows 10, you're good to go. There's nothing more that you typically really need to do when you work with client, because typically everything is else in terms of the services, or in terms of what you need to do, in terms of what the actual OS can provide for you is typically automated. But now it's not the same when you look at installing server software. So just installing the server software on its own is not enough for your machine to function as a server. What you then need to do is add what they call specific roles that you'd want that particular server to, or that particular machine to provide for. So ultimately, what I mean is, once you install the Windows Server 2012 Release 2, you'll then need to specify that I want this server to function as a DHCP server. I want this server to function as a file server. I want this server to function as an Active Directory platform. So how you do that is add what they call roles, which is now specifying what that specific a server is supposed to do, or what that specific software for you is supposed to do. So it's imperative for you to understand that distinctive fact. So ultimately, once you've done that, like I was saying right at the beginning there, is to enable client and machine to communicate. So again, like I've said before, just connecting them, if you are looking at it from a physical perspective, where you've got your client, you plugged in your cable, you plug it into a switch, and you've got another cable that is plugged from the switch to your server, it's not enough in terms of linking those two machines, because you now need to configure it appropriately so that the client can see the server, for lack of a better term, and at the same time the server can see the client, and they can exchange communication across the board there. So, like I was saying, once you run these machines simultaneously, you'll need to boot your client at the same time you boot your server, and then you need to show that particular communication. So there needs to be, you need to take screenshots in terms of the DHCP role being incorporated appropriately, and then ultimately your particular client being able to automatically get an IP address from your distinctive server there. And I think, yeah, one of the other parts as far as the actual PoE there is concerned will show a need for mapping a home drive, and also a need for you to be able to log in to the actual network as far as server configurations there is concerned. So ultimately, you need to then create users on your server. The same, okay, to make it to make the explanation short, the same thing that you guys do when you walk onto campus and log in, that's what you're actually mimicking in this virtualized environment. Remember, if you walk into the library, you walk into the computer rooms, you incorporate your electronic credentials, username and password, and then you're granted access to the network resources. It's exactly the same thing that you're going to be incorporating as far as this particular part of the PoE is concerned. You will need to log in from your client with whatever username and passwords or electronic credentials that you'd have configured, and then naturally be able to access services that the server is providing for. So you're actually mimicking what actually happens on campus when you actually access any one of the computer rooms or any one of the computer systems that are there. So you've got that as a minimum for the RAM that you'll have incorporated. The other thing that you'll also need to take into consideration, I think let's go back to using our standard black ink there. The other thing that you also need to take into consideration is going to be the storage space that you've got. So as far as the actual hard drive is concerned, you'll need at least 100 gig. Let's say free storage or free space. As far as the actual hard drive is concerned. So what we are looking at is at least to have, at a minimum, you'll need about 25 really for your client, and about 40 for about 40 for the server. But I think just to make everything a bit more fluid, that would then mean that as far as this year is concerned, let's just put 50 GB for client, and then obviously another 50 GB for your server. All right, so you need to have that incorporated, and then when it comes to, so I think that is sorted there. Obviously, what you can then ultimately do is then obviously use the cable that actually, because we're not looking at this from a physical perspective, then that's fine. I was about to mention that we're using the cables to physically connect the machines, because this is obviously in the virtualized environment. So what it would mean is the virtual platform that you'd use would act as your switch, or act as a connection point between the client and the server machines that you'd have incorporated there. So that one is sorted. So ultimately, what you'll also then need is to use virtual. You'll need to then download and install VirtualBox. Whichever version, honestly, would still work appropriately. Sometimes might be applicable just to go with the latest version off the site. But typically whichever version that you've got should be good to go. And then as far as the actual softwares are concerned, like we mentioned before, you will need, so this would be our virtual platform. So VirtualBox would be then the virtual platform that will provide for us loading these machines. And then what you'll also need to take into consideration is obviously the actual software. So remember, we said you're going to go with Windows 10 Pro, all right? And this is a given really, but let me just mention it, 64-bit. And then also you will need Windows Server 2012 R2. Again, 64-bit configurations there. All right, so then that you should be good to go as far as that specific setup is concerned. So this is the just make sure you've got this just incorporated beforehand. Just make sure that is set up beforehand. So at least when we start undertaking the practical part, and obviously the illustrations in terms of what it is that you need to do, ultimately probably just after the sessions, you can then start working on your virtual machines to make it a lot easier, rather than just then trying to find or trying to sort out your situation when we are doing this, because it can jeopardize in terms of time. So just to avoid having to, obviously getting overwhelmed with content and whatnot, just make sure you've got that incorporated. I think I did mention this in our previous sessions, but I just thought it's important for us to have it on record, really, in terms of probably just having a couple of slides that would represent that. And then ultimately, you can always use that as a reference point in terms of getting the content that you would need. So just to go back again, so PoE, this is part of the PoE actually, because I think you've got the cable part, like I was saying earlier on, but the main part is for you to look at connectivity, and then you'll have several questions that will then ask you to manually set your IP addresses, especially obviously on the actual server itself. And then as far as that is concerned, then create those scopes. Remember, we mentioned DHCP before, and we said that it's a platform that has been designed specifically to automatically assign IP addresses within any given network configuration or architecture. So ultimately, you'll need to configure that on your server, create a scope, and then as far as that same scope there is concerned, that is what you will also need to show proof of, in terms of screenshots when you log in with the client, and obviously to see that that particular client has been part or has joined a distinctive work group or a distinctive network, because remember, you're also going to create your own you could say fully qualified domain name platform there, that is also going to be configured on that distinctive server, because you'll also have what they call Active Directory services, which is a platform that will then enable you to create the usernames that are going to be used as far as your network environment there is concerned. So that is part and parcel of what needs to be created, and obviously a linkage between the two machines need to be shown. And then, like I was saying before, what you are looking at as far as the actual requirements, your process obviously needs to be capable of virtualization. You can activate that in BIOS first before you start working on the platforms. But again, something that we can show when we actually look at the practical part of this. And then obviously the RAM that you'd need, make sure you've got that as a minimum, really. To be honest, some might argue that obviously if you're working with 4 gigs, you might still be able to get away with it. But to be honest, the experience would be really uninvolving, for lack of a better expression. So you'd rather make sure that you've got enough hardware resources incorporated there. Same difference would go with your storage, and then obviously the virtualized platform software that you need. And then, so these, as far as this particular, this will need to be an actual ISO. So both of these would need to be ISOs. All right, so just get images of, I think, if I'm not mistaken, there's that FTP site on campus that has all the softwares that you need. So you can get it off there or download it off your own volition in your own environments there. But like I was saying before, just make sure that when you get these particular platforms, they are ISOs or images of those distinctive softwares there. And then obviously you should be sorted. So do we have any questions on this? Obviously, like I said before, we will have, I think after the next 2 or 3 sessions, after then I'm probably just looking at it from a theory point of view. Just obviously, like we said today, looking at the whole issue of access methods. We're going to be delving into understanding what's happening with enterprise networks, also specifying those distinctive roles that the service can provide for, and ultimately also looking at what is happening as far as basic cabling configurations would go. And then probably discuss topologies again in a bit more detail, and then we can start working on this, because at least you'll have some kind of background idea or some kind of understanding of what actually happens from a theory point of view. And then if you then apply that to practical, it becomes slightly easier. Okay, so any questions on this? Anyone, any questions or contributions on this? Any questions? Oh, yes. And then I think the other thing as well, so this is for the POE. So this is more associated with task number 2. I think for task 1, now, so one of the softwares that you'll need, let me just state this as task 1, if I'm not mistaken. One of the other softwares that you'd obviously need would be MS Visio. I said, because I think there's one of the questions that will ask you to design a network. So you need to come up with a network diagram. So as far as that is concerned, you need to specifically use Visio, not or any program that has network icons that you can then obviously use as far as coming up with a network diagram in there is concerned, trying to avoid using, I'm not so sure if Word has incorporated that content yet, but I think there's a tendency I've noticed with this question that people just end up putting in triangles and then representing those triangles as computer systems or servers and whatnot, rather use a program that has been distinctively designed or has the appropriate icons associated with your distinctive network components. So Visio is good at that, but it's not the only one that you'd find. I think there's a couple of other programs as well that will have network devices incorporated there. So you go with Visio as a default, and as far as the Visio is concerned, like I said before, it doesn't really matter which version that you go with, because you can go, I think, 2013, you can go 2016, you can also even go 2019 as far as your setup would go. So anyone that would use, as long as you can appropriately configure a network a diagram there. So that's one of the programs that you'd need. Obviously, the generics would still apply in terms of you looking at the theory part associated with, the questions for task 1. Okay, so I think that does that as far as the requirements. Like I said before, we've discussed this, but just to make sure that we're all on the same page to avoid any misalignment associated with your assessments. All right, some might want to argue why going with 2012, but it makes it a lot simpler and easier for you to understand. I think 2016 leans towards, is a massive inclination really towards more cloud-based configurations when it comes to server. So 2012, I think, for the purposes of just understanding that or illustrating that connectivity and setup would be appropriate in our distinctive setup there. Okay, so do we have any questions here or contributions? Let me just check if I've got anything on chat. Something has popped in here. Does it have to be specifically Windows 10 Pro? Yes, Aduka, it has to be. There has to be. To be honest, I think arguments can still exist with 10. I'm sorry, with 8.1 Pro as well. But I think just for uniformity's sake, let's stick to 10 Pro. Why Pro? Because remember, Pro enables for those networking capabilities. Home can be problematic because it then makes it difficult for you to join a distinctive work group in terms of what the actual software package provides for. So yes, it does have to be Windows 10 Pro. Like I said before, you already have those softwares uploaded for you on the FTP site. As far as like the campus setup there is concerned, so all you have to do is just download what is distinctively relevant there. So yes, it does have to be that. Any other questions on this? Are we all on the same page when it comes to your requirements? All on the same page. So like I said before, I think after the next 3 sessions, we will then concentrate more on the POE part really, because I think it's imperative for us to then look at it from a more practical point of view, to look at certain content that you'll then use in the industry, or use on a more practical point of view. So there will be maybe 1 or 2 certain sections that we will probably superficially talk about, and then concentrate on the content that is relevant for your POEs or your assessments. Okay, so any questions there or any contributions? Super Chic is sorted. So I think everyone else, I'm assuming the silence from everyone else means that we are good to go. All right, sorted. So the last time we had sessions, like I was saying, I think we had just discussed the OSI model and then moved on to understanding what's happening with the IPs. We did that session that looked at the different classes associated with IP version 4, specifically how subnet masks function and what's happening as far as different portions of the IP address there is concerned, looking at the network portion, looking at the node portion, and ultimately, so like I was saying, looking at obviously the whole concept of the IPs, which is a network portion of your IP version 4 address, which is the node portion, and or which is the host portion, and then looking at how subnet masks obviously provide for that basic indication. I think it's also important for you to understand when you're looking at the different types of network that networks that you've got configured or running with, what you're typically looking at in essence is the fact that, okay, look, if I've got a scenario where I've got a lot of networks and then I'm sitting with a few or a relative number of gadgets or devices within these networks, I'd probably go with a class C address. If I'm looking at a balance between the two, class B would be my go-to. And then naturally, if I'm looking for a scenario where I've got less networks, but I've got a larger number of hosts that I need to configure in each one of these networks, then class A would be my default go-to. I think we also discussed the whole concept of the different or the variable length subnet masking platforms or the CID/R notation. It was just important for you to then understand that when you're going to be incorporating this, especially for your assessment, and not obviously, remember, it's not just limited to your assessments, but obviously when you're using it in the industry or within your own professional or personal spaces, you understand exactly what's happening with assignment and obviously how it assists with proper configuration as far as your specific networks are concerned. So we want to look at comparing now what's happening with the different access methods that are there. So we talked about the IEEE, and we said that this is obviously a non-profit making organization so electrical and electronics engineers, Institute of Electrical and Electronics Engineers, that's there to kind of standardize the way in which network platforms function. And they developed, so IEEE developed the 802 standard, right? Or the 802 platform. So the 802 standard that looks at a variety of architectures that enable us to understand how configuration takes place as far as your distinctive environments there is concerned. So we'll look at about 15 of them, 1 all the way to 16. I think 13 is blank there or doesn't have any distinctive assignment. So in total, you've got about 15 configurations that are associated with your particular platform as far as the IEEE setup is concerned. So ultimately imperative. I think one of the other things as well that you also need to look at understanding is the conversion I was talking about earlier on. I think we mentioned that in order for data to be successfully sent from source to destination, what typically happens there is that particular data needs to be configured or converted into an actual signal first. And as far as that there is concerned, these signals can either be analog or digital. Normally, when you're looking at digital signal conventions, because remember, digital signals, like we said before, deal with or are associated with voltage pulses ultimately. So you've got certain conversion techniques that are there, or signaling techniques that are there that you also might need to familiarize yourself with. So typical examples of that will be unipolar, bipolar non-return to zero, bipolar return to zero, and Manchester encoding. So these are just techniques that are used to then transmit that data or to work with digital signal formats. I think we'll look at it a little later on in today's session just to see exactly what happens with probably a specific bit stream associated with your distinctive environments there. All right, so typically it's probably towards the end of today's session there is concerned. So the first thing that you want to look at is the 802 802.1 standard. All right. So what's happening with 802.1? This specific standard now deals with your local area networks, as well as metropolitan area networks. And ultimately what's happening there, it's all to do with what they call bridging and basic management. So the 802.1 platform deals with local area networks and metropolitan area network configurations. Remember, like we said before, metropolitan area networks are those networks that have been configured within the central business district of a specific locality or the municipal area of a specific locality. So you're looking at basic standards that define the way in which certain devices would function within these particular architectures. So ultimately, the reason why obviously remember a bridge is also associated with a specific device, but again, if you're looking at it from a different perspective, we mentioned that anything that enables connectivity to an external network is normally just associated with the term gateway, which is then distinctively associated with our routers, and these routers would then enable a linkage from one particular part to the other. Remember, we talked about pathways. And these pathways are obviously configured by basic routing mechanisms associated with your environment. So this one deals with LAN and MAN bridging, as well as management. Right. So just basic setups that looks at distinctive pathways as far as your setups they are concerned. The other ones that you also want to take into consideration, the 802.2 standard. This one now deals with your LLC. All right. So remember what the LLC stands for, your logical link control. And we've mentioned this before that the LLC functions in your data link layer as far as the OSI model is concerned. And remember, we mentioned that the specific differences with LLC, you've got type 1 and type 2, if you remember well. So you've got LLC 1 and you've got LLC 2 there. And what's happening as far as these particular platforms is concerned, one is connection oriented, the other one is connectionless as far as configurations would go. And then ultimately, if you remember what we mentioned before, with these particular architectures, when it's connectionless, a link between the entities within your network is not established first before transmission takes place. And then on the other hand, when you're looking at connection oriented, some kind of acknowledgement has to be sent by the receiver to make sure or to confirm that distinctive messages have typically been accessed. And then if you look at the other platforms that you've got associated with the 802 standard, I think the third one that you want to discuss is the 802.3 platform, and this one is called the CISMA CD access method. And what that typically stands for is, so this CISMA CD platform stands for carrier sense multiple access with collision detection. All right, so that's what your CISMA CD stands for. Normally, this particular standard was used with generic Ethernet platforms, and ultimately, I think if you remember when we discussed, if you look at it from a diagrammatic point of view, we looked at one of the topologies, and we said one of the topologies that is associated with network configuration or layout or a setup is the bus topology. And in a diagrammatic representation, we had something along these lines where we had those particular connections being computer systems as an argument. And remember, we mentioned there's 1, there's 2, there's 3, there's 4. And at these particular points, you've got what they call terminators, and obviously also at these particular points, these are connection points within your setup. So back in the day, this was normally associated with coaxial cabling platforms, but later day standards can argue that it's more associated with backbone configurations. So now what this would mean is you've got one so this is a bus topology. All right. So remember, we've mentioned a bus is a communications channel generically when you're talking ICT. And ultimately, you've got one particular link there that is enabling all those three computer systems to function, or those four computer systems to communicate. And we've mentioned that these particular parts are known as terminators to avoid what is known as a signal bounce. So what that typically means is if a specific signal is not captured when it's transmitted across that one single line, link, or cable, ultimately, once it reaches the end of the cable, it needs to be killed off the actual network, because if that doesn't happen, what takes place is that it bounces off one end until it gets to the next end, bounces off that end and comes back again. So what that typically means is that your network can seem busy when it's actually not distinctively utilized or used. So to avoid those kind of scenarios, you need to incorporate terminators at the end of those of that particular setup or cable to avoid that signal bounce, as far as we mentioned before. So what typically happens now is that since you're utilizing one distinctive cable, there's bound to be a lot of collisions because data can be sent in, or these computer systems can try and communicate in a simultaneous fashion. And when that happens, it means that the signals are collide, or data packets collide. And obviously, remember, like we said before, once these packets collide, ultimately they become useless. So technically what's happening with carrier sense multiple access now, though the carrier sense is distinctively just looking at listening to the cable first, or listening to the network to identify whether it's busy or not. Multiple access part is just having one distinctive link that is used by every other machine that is connected. And then the collision detection part is if collision does take place. All right, so you've got simultaneous sending and receiving. So let's just say one is sending at the same time that a four does. Ultimately, if their packets do collide, or whatever signal platforms collide, there needs to be some kind of mechanism put in place to identify that collision, to alert the network to say, okay, look, there's a collision that has taken place. Ultimately, data or signal platforms need to be resent. So what normally then happens is there's a back off period where if data is collided, probably just for argument's sake, number one would need to wait for 5 milliseconds, while a four probably might need to wait for 3 milliseconds. So what that then would mean is that once four sends its data, again, the other systems would then need to listen to the cable or listen to the network. And if that particular network is busy, probably they don't send. But if it's not, then ultimately that means that the network is free for utilization. So the whole purpose of looking at the whole concept of multiple access and collision detection is just to avoid discrepancies that might arise as far as your network transmissions there is concerned. So normally your Sysma CD will function with your bus topology configurations as far as your particular setups they are concerned. You also have what they call collision avoidance, but that's more applicable with wireless communications as far as distinctive architecture is concerned. Looks like something came through in chat here. Let's just check if it's someone trying to log in, or okay, someone trying to log in. Okay, cool. All right, so that's how your Sysma CD typically functions as far as your specific environments there is concerned. And then if you look at the other one now is going to be the fourth one, which is token ring passing. So you've got the fourth type of standard is the 802.4 architecture, and this one is associated with what they call token. So this is a token passing bus access method. And as far as this particular platform now is concerned, it uses the benefits of the token ring. So in order for you to understand this, I will need to actually discuss the fifth one, which is your token ring access method. Because remember, when you're looking at scenarios associated with your specific environments there, a token is more or less a packet, right, that traverses the network, and it's something that gives devices the go-ahead or the sole right to transmit. Everything else that's in that network that doesn't have or doesn't possess or doesn't or hasn't captured the token will only wait for reception of signal or reception of any particular data that's coming from that specific machine, as far as conventions would go. And obviously what that would then do is try and avoid, again, the collision that was mentioned a couple of seconds ago. So arguably, in this particular platform, data actually travels the actual wires in the form of a ring. And 802.4 is not really used in LANs or PC networking. If you want to look at it from a different perspective, it's actually used in specialized manufacturing control systems that are configured as far as your a specific setup is concerned. So to enable you to look at a generic understanding of this, if you look at the 802.5 standard, which is your token ring access method now, access method. Remember, your ring is configured in something along these lines. Obviously, something that is in circular format. Computer systems 1, 2, 3, 4, and you've got your ring configured like that. More often than not, communications is in an anti-clockwise direction rather. So technically what that means is that you've got a token that continuously circulates that particular network, and that token is just a packet or an indication packet, if you want to look at it from a different perspective. So that packet is what gives computer systems the sole right to communicate. So as there's an argument's sake, you've got a token that is circulating there, and then as far as that particular token is concerned, let's assume that device 3 there captures the token. It means that the network now is busy, or is indicated as busy, which means that if it's busy, no other machine or no other device can typically send anything. They wait for reception, and once that particular sending has been done, that token is released. So arguably, like I've said before, once device 3 captures the token, so 1, 2, and 4 cannot send any particular data as far as that particular network is concerned. And then once 3 is done, it releases the token to circulate the network again. And any particular machine, like I said before, that would then need a usage of your specific environment, they would then capture the token for the sole right or for the sole purposes of communicating. So normally you find these particular rings in more in a logical format, dependent on network configuration. But remember, like we said before, if you're looking at it from a fiber perspective now, you normally have 2 rings incorporated where, and this is normally associated with your metropolitan area networks now, where one particular ring or one particular link, rather, whichever way you look at it, is used for sending. The other ring is used for receiving, dependent on configuration as far as your specific setup there is concerned. So that's 802.5 standard. I think when we were discussing the OSI model, we mentioned that within your physical layer configurations, you've got the 802.3 architecture, which is that SysMA CD, or which is associated with Ethernet configuration. And then you also have the 802.5 standard, which is a token ring access method, which is just discussed now. And then you also have the 802.11 architecture, which is distinctively designed, or which was distinctively designed as far as Wi-Fi connectivity is concerned. All right, and then you'll find that the sixth one that we have there. So you've got 6 again, 802.6. And normally this is associated with what is known as the distributed queue dual bus access method. And again, this was designed specifically for metropolitan area networks. And again, what's happening, you've got 2 parallel cables within a bus network topology. And obviously, each one of these cables are used to transmitting in basic or different directions. So devices can typically either send and receive in any one of the directions associated with your specific environments there. And it also works in a setup where it uses fixed size data packets for better manageability, and to some extent you can also even argue for security purposes. So this one is what they call the DB or DQDB rather access method. And like I said before, short for distributed queue dual bus access method. And again, this is working with the standard that was developed. So we can just mention here that developed mainly for metropolitan area network configurations there. Obviously, it uses parallel cables in a bus topology configuration as far as architectural setups they are concerned. On the other hand, you've got the 802.7. So this one now is associated with broadband. What we are all familiar with, although this is looking at broadband LAN configurations. So this is for installation and basic testing as far as broadband transmissions are concerned. And it allows for obviously multiple transmissions distinctively using different channels at the same time. And it supports what is known as multiplexing. So if you look at multiplexing, normally this is an architecture that was designed to combine multiple low-speed networks or low-speed channels into typically one high-speed channel for cost reduction and also for better speed. So if you were to look at it from a diagrammatic representation, normally your multiplexing would function in this particular fashion, where you've got computer system 1, computer system 2, and 3 there. And then probably you could also argue that you also have another dedication in terms of the machines that are configured maybe at that particular end. So this is just for basic illustration. So you've got 4, 5, and 6. These are all computer systems, right? Then you've got some kind of multiplexing device. So from a basic point of view, you've got a multiplexer there, and then you also have another multiplexer maybe there, all right, for argument's sake. So you've got multiple low-speed lines that are coming from 1, 2, and 3 there. So that let's represent the data that is coming from 1 as 1, 1, and maybe 2, 2, and then 3, 3. And then you've got that link there, and then obviously you've got separation there. So you've got a multiplex and a demultiplex. A multiplexer combines at the sending end all right, and then a demultiplexer at the receiving end would then separate. So technically what's happening there is that you've got multiple low-speed lines that are coming from 1, 2, and 3, and these multiple low-speed lines are then combined by the multiplexer into one, so that they can be transmitted over one high-speed line. And then obviously at the receiving end there, you've got a demultiplexer that then separates. So let's mention this specifically here so that we've got it appropriately. So we're talking about multiplexing. So you've got a demultiplexer at the receiving end that then separates these specific platforms there. So now normally you find that so as an indication, what it would then mean if it's combining, it doesn't just take, it takes bits and pieces from each one of the connected machines. So a specific packet, if you've got interception of whatever transmission that is there, it's slightly secure to a certain extent, because what then normally happens is that the data that is being sent across would look something along these lines. So a bit from one, a piece from two, a piece from three, and then another packet there. So let's just represent that in that fashion. Another packet, 1, 2, and 3, something along these lines. So you can imagine if this particular, or the first data packet was supposed to be intercepted, that data doesn't really make much sense, because it's only a bit from 1, a bit from 2, and a bit from 3. And ultimately, it presents some kind of security to a certain extent. And then assuming that computer system 1 is sending data to computer system 6, what the multiplexer, the demultiplexer at the receiving end now would do is then subdivide that, or separate that particular communication to say, okay, that is data coming from 1, and assuming that 3 is sending data to 5, you get that there, and assuming that your 2 is sending data to 4. You've got something along those lines as far as configurations would go. So basically, what a multiplexer, like I said before, is responsible for just combining multiple low-speed lines into one high-speed line. You've got a multiplexer at the receiving end, and that multiplexer is normally known as a demultiplexer. So something that separates those that combination. Or those combined lines, a demultiplexer, something that combines them, is obviously called a multiplexer platform. As far as your setups there are concerned, in certain literatures, you'll actually find, depending for ease of reference, these particular devices being represented as MU configurations there, short for multiplexing. Okay, so that's your broadband LAN configuration there. And then if you look at the 8th one, you've got the 802.8 standard, and this one deals with fiber optic for a local area and metropolitan area configuration. So your fiber optic cabling, so this is fiber optic platforms for LANs. And metropolitan area networks. All right, and ultimately, what's happening there? It's basic recommendations for the setup and the testing or the configuration and the testing of fiber optic LANs and fiber optic metropolitan area network configurations. And then obviously this just looks at making sure that whatever fiber optic cabling platforms are used, stick to us, or the setup is integral, or there's some kind of integrity associated with a basic setup there as far as your specific environment is concerned. On the other hand, you also have the 802.9 standard, and what's happening there, you're dealing with what they call integrated services. All right, as far as integrated services there would go, is just basic access to both public and private backbones. Remember, a backbone is normally a high-speed network rather, that then feeds into multiple local area networks in certain environments, multiple metropolitan area networks in certain environments. So you're looking at basic integration as far as those public and private backbone configurations, like your fiber distributed data interface networks there. And it typically also looks at the MAC configuration associated with your physical layer interfaces. And at the same time, just again, like I said, looking at internetworking of different sub-networks that will then form part of a much larger network. Remember, when you look at those global area network configurations we talked about, or wide area network architectures, it doesn't just exist as a wide area network on its own. More often than not, these are multiple local area networks rather, and the metropolitan area networks that have been configured to then, or that have been then linked on a much larger geographic space to create your wide area network configurations there. So it's all to do with backbones, really, as far as your specific platforms they are concerned. So one of the other things that you can discuss there is just backbone architecture. And again, as far as these backbones are concerned, you're looking at both private and public backbone configurations. And then with the 10th one, the 802.10 platform, now you're dealing with security. Remember, it was going to be near impossible for us to discuss anything to do with these standards or these architectures or these platforms without distinctively discussing what's happening as far as basic security there is concerned. So the 802.10 platform specifically deals with LAN or metropolitan area network security. Just to make sure that there's some kind of protection as far as your network environments are concerned. Remember, with ICT, nothing is 100% secure, but like we've mentioned a couple of times before, you can try and make it more difficult for intrusion or for illegal or unauthorized access. But ultimately, no system is 100% secure as far as your specific environments they are concerned. So this is when you're looking at working with security association identifiers, obviously specifically looking at just basic security within both LANs and metropolitan area networks. So ultimately, these are standards that have been distinctively designed just for the sole purposes of making sure that your environments are ultimately secure. And then on the other hand, you've got what we are familiar with now, which is the 802.11 standard. And then remember, this one deals with wireless LANs, all right, or typically WLAN. And you've got different standards that are typically associated now with your 802 configuration. All right. I think the specifics that we've mentioned before, as far as your specific environment there is concerned, is just understanding specifically what's happening in terms of frequency as well as distinctive speed. So you've got different types of configurations that are there. Again, like I said before, looking at the differences between the actual speeds associated with your setup there, as far as your distinctions would distinctively go. So a frequency obviously is looking at connection as far as your specific setup there is concerned. Again, like I was mentioning a couple of seconds ago, what you're actually looking at is a speed. So you've got devices that are configured associated with the different 802.11 standards. And I think some architectures are backward compatible, some are not. So it's imperative for you to understand specifically what's going on there as far as basic connectivity is concerned. So the actual frequencies that you're looking at, so not basically inclusive, but not limited to, you've got 2.5 gigahertz, you've got 5 gigahertz, you've got 6, and in some instances, you can even talk about 60 gigahertz as far as basic frequency bands they are concerned. So from a frequency point of view, oopsie. So from a basic frequency point of view, you can discuss 2.4 gigahertz. You can look at 5 gigahertz. You can also discuss 6 gigahertz, and you can also mention 60 gigahertz platforms there. So again, not really limited to that, but ultimately, like I said before, you're looking at it from a basic setups as far as your environments would go. So you've got different standards that are there. So you've got the 802. So here you can talk about the basic 802 standards that are there. So you got 802.11. You can talk about 802.11a. You got 802.11b, 802.11g, 802.11n. You can also even mention 802.11ac. So these are some of the classic examples of the standards that are there. And ultimately, you can also even discuss, so C to F, H, and J can still be incorporated there in terms of representation, but ultimately, these are all basic service amendments normally that are used to typically extend the actual current scope as far as the actual existing platforms that are there. And these might also include certain corrections of previous specifications that are associated with your environment. So when you look at the 802.11b and G standards, these normally use the 2.5 gigahertz platform as far as your configurations would go. So ultimately, if you look at these two, that's normally 2.4 gigahertz as far as setups they are concerned. And then ultimately 802.11 can also use that distinctive band. So you can, that's the reason why you normally find that as far as your specific devices are concerned, just as a basic setup, you normally might find that you've got them labeled as 802.11 B, G, and N, which means they can work across distinctive platforms as far as your specific environments they are concerned. On the other hand, 802.11a uses the 5 gigahertz band, and some of these devices were not really we could say forward compatible. Why? Because if you needed to use 802.11 configurations, you then 802.11a configurations, on the other hand, you then would need to use 802.11 configured devices. So it was a bit problematic in terms of conventions that are incorporated there. And then ultimately, as far as basic AC standards that have been configured, these are slightly newer protocol architectures that only uses the 5 gigahertz band, so 802.11. So with A, you can also use 2.5 and then a 2.4 rather, and then when you look at 802.11 AC there, this only uses, so strictly, so this one only uses the 5 gigahertz platform as far as specific setup they are concerned. So slightly newer standard, you find that most of the laptops that are being designed, or most of the portable platforms that are being designed now, normally work with the 802.11 AC architecture for faster communication, faster speed, as far as setups would go. Some might even want to argue that obviously the higher the frequency, ultimately the faster the communication as far as your environment is concerned, and to some extent less interference that you'd get elsewhere as far as your specific setups they would go. So 802.11 distinctively wireless as far as your specific environments they are concerned. So ultimately, it's imperative for you to just get a distinctive understanding there. So you've got obviously also different speeds associated with connectivity. So if you look at 802.11a, you get about 54 megabits per second as far as basic wireless output is concerned from a configurative point of view. So it's all to do with the basic choices and configuration associated with your environments there. Right. Any questions or contributions on this as far as these 802.11 configurations they are concerned? I think most of you are familiar with these. Any questions or contributions there? Remember, 802.11 AC is also known as Wi-Fi 5 as far as configurations would go. 802.11 N, Wi-Fi 4, AX, which is an upgrade, Wi-Fi 6 as far as basic configuration is concerned. You also have what they call Wi-Fi 6E as a addition to what is happening as far as connectivity is concerned there. All right. So certain terms that you'll find associated with these for better understanding. I'm not so sure if this will still be legible there. So this is Wi-Fi 5. N is Wi-Fi 4. And then you've got the G and the N's and the A's as separate platforms as far as your configuration would go. And then you also have 802.11 AX, which is Wi-Fi 6. All right. Okay, so any questions on this? Questions or contributions or concerns on wireless architectures? Okay, cool beans. Okay, so there's a question coming in. Who is it that was questioning? Yes. What's our question there or contribution there? Or am I mistaken? I thought I had someone say something here. Okay, cool.
I have no questions, so.
Okay, cool. Not a problem. That's fine then. All right, so let's look at the other standards which you've got here as far as your specific environments are concerned, which is 12, and this one is 802.11.12 rather, and this one is dealing with what they call high-speed LANs. All right. So as far as high-speed LAN configuration there is concerned, this deals with what they call demand priority. So it's dealing with the physical layer that's supporting 100 megabits per second transmissions, obviously, and above as far as configurations was concerned. So demand priority access is typically a method that places the actual responsibility of network access to control the actual switch or central device from the actual workstation to the other device that is looking at providing demand priority as far as routing communications is concerned. So remember, when something is demand priority, is given preference as far as basic comms there is concerned. So high-speed LANs are just dealing with the demand priority access method that looks at responsibility of transmission on the actual centralized device associated with your configurations there. So normally your switch in this particular instances. So this one deals with demand priority access. And then you've got, remember we said that 13 not included there. So our 13th one will actually be 802.14. And this one is dealing with cable TV. Access method. And then as far as this is concerned, just provides frequencies based with digital comms. So it's all to do with looking at cable television and working with a specific preference as far as basic digital communications there is concerned. Then we've got the 802.15, and this one is your wireless PANs now. Wireless PAN. Remember, PAN is personal area network. So ultimately, when you go, this is to be honest, this is more or less just Bluetooth. Ultimately, because we've mentioned this before, personal area network, some network that you've configured within your own personal space, so your Bluetooth-enabled headsets that are then connected to your tablet or your smartphone or your laptop, whichever gadget that you're using. Ultimately, that's a personal area network that you've typically configured. So you've got obviously a standard that was developed to look at that distinctive space there. So ultimately, it's just all to do with Bluetooth associated. So here, I think maybe to make it more specific when it comes to our PANs, this is just really dealing with the whole concept of Bluetooth. All right, and then lastly, what we've got as far as these particular access methods they are concerned, you will need to look at. I think this is our 15th one. That's then going to be. Let's see if we can write our 5 properly there so that it's not confused as a 6. So this one now is just strictly, it's an 802.16 platform that just deals with a wireless metropolitan area network. All right, so this one is dealing with a wireless metropolitan area network configurations. Excuse me. So it's actually a broadband wireless communication that obviously has been developed specifically to enable multimedia applications with wireless connections having a specific range, and your normal range there is about 45 kilometers or 42 kilometers, which is normally about 30 miles, dependent on conversions, if I've done that appropriately. So that's the distinctive setup that you've got there. Wireless LAN architectures that specify a specific range. So I think you're looking at about 45, 48 Ks, if I'm not mistaken, which is about 30 miles as far as your basic range configurations would go. So that's the typical setup that you've got as far as access methods they are concerned. Ultimately, remember with your networks, you never really have something that exists as a sole entity more often than not, or that exists in a vacuum. Those topologies that I was talking about earlier on also look at that they don't exist as lone platforms, don't exist in a vacuum. Why? Because normally it's combined. You've got combined topologies, combined architectures to make what they call a hybrid network that would then obviously function more appropriately or more efficiently, whichever way you look at it, as far as your conventions would go. Because remember, in each one of these infrastructures, each one of these architectures, you've got distinctive drawbacks that if you solely use just one, those drawbacks can detrimentally affect the way you've configured your network or detrimentally affect communications within any given environment. So what you'd want to then do ultimately is to have a hybrid setup that will then enable comms to work appropriately as far as your specific environments there are concerned. So ultimately important for you to take distinctive cognizance of. And then obviously when you look at the whole concept of the TCP/IP or the TCP/IP platform, which is ultimately one of the most basic network protocols that you'd find that is used across any distinctive platform because it's an open standard. It works when it's open, it obviously means that it works with several architectures, several operating systems without any distinctive problems. But then you also have proprietary architectures that were designed to work within specific environments, like the Apple Talk configuration that was designed to work between or to work with devices that are using the Mac OS as far as configurations would go. Some might want to argue that this was normally associated within the educational setup as far as these Mac-based systems they are concerned. Remember, some of the biggest problems that you can find with proprietary architecture is that it's difficult to integrate with anything else. Why? Because it's been specifically designed for a certain institution, a certain environment, a certain platform. So your open standards become more appropriate in certain instances. Why? Because at least they can be used across any distinctive setup. We've mentioned DHCP before, so that's something that you are familiar with as far as automatic assignment of IP address configurations they are concerned. You might also want to touch on what is called SNMP protocol, which is your simple network management protocol. And this one is also looking at just enabling remote configuration and monitoring as well as management of network devices within any particular setup. So SNMP arguably also works on the application layer as far as the OSI model is concerned. So its main purpose is just looking at remote config, remote monitoring and remote management as far as your specific environment there is concerned. So I think that is that when it comes to access methods there. So look through, I think, chapter 3 again, as far as your prescribed text is concerned. It again just discusses the whole concept of what's happening with how you would typically send and receive within certain environments. So these 802 standards in general are quite important for you to remember and understand specifically in which environments they function and obviously why they've been designed and configured. And then what we would then want to also do is, I think the next time we've got sessions, that should be on the Tuesday next week, if I'm not mistaken. We'll then want to look at what's happening with understanding exactly basic network architectures that are there. This will then delve more into server-side computing, just discussing exactly what kind of services are available and how your server platforms function. So that at least this gives you an idea now that when we go to our practical, when you start working with the actual POE, as far as basic assessments are concerned, you understand exactly what your server is typically supposed to provide for as far as your networks are concerned. So that should be our fourth learning unit. Then enterprise networking, I think we can discuss that also before we start the practical. I think it's just, although I think maybe after that session on Tuesday, I think I'll see you again on Friday. On the Friday of it, maybe we can then start talking about how we can set up our virtual environment, just looking at what you need to incorporate and how you can probably start playing around with just basic installation first before we start moving to a linkage of your client as well as your server. All right, so I think that we can start discussing after Tuesday's session. If there's still any questions that still need to be attended to beforehand, we can always tackle those accordingly. All right, questions, contributions from the floor there. Any questions or contributions from the floor? Questions, contributions, concerns? Is there anything that you might need reiteration there or clarification or something that you want to contribute, something that you want to add on? Anyone?
I'm good for now, sir. I mean, look, if anything pops up, I'll drop you a mail.
Not a problem. That's fine. Works for me. Right. Anyone else there? Or are we sorted? I've got something coming on chat here. Let me have a quick look. Ibuka is sorted. Okay, cool. I'm assuming Okay, Bryden, sorted. Okay, sorted. So it looks like everyone is good to go. That's fine then. Okay, guys. I'll save the presentation as usual and send it through a little later on. And then I think this session is also being recorded, so I'll post this on YouTube should you need to go through this content again. But otherwise, if we don't have any questions or contributions or concerns, then it means that we're sorted. Stay safe as usual. Keep smiling and stay positive. Don't get carried away. I've said this a million times now. Level 2 can be detrimental, so stay vigilant. We still have this virus for a while. All right. Cheers, guys. Keep well.
You too, sir. Take care.
Thanks, man. All right, Komani, do you have a question there? So your hand was up in a bit. Okay, cool. Not a problem. Cool beans. Thanks for attending. Jared, you good there? Okay.